the payload. We're going to hit the mother load now, adding and subtracting rational expressions. So I'm going to give you guys a chance here. I'm going to talk slow so you can be writing and getting this information down in those math notebooks that are organized. 4 steps. And this is really 4 steps for adding and subtracting any fractions. Step 1, get that least common multiple. Now we're going to call it the least common denominator. Now notice I wrote that's 90% of the battle. If you can get the LCD of these fractions, you're going to be successful. Factor the denominators if necessary and break all numbers into the prime numbers. Multiply each factor the greatest number of times that it appears in any one factorization. Okay, step 2, make equal fractions with that LCD. Step 3, add or subtract the numerators depending on the problem and put over the LCD. And step 4, always look to reduce, and we have already practiced reducing these polynomial fractions, so those are the 4 steps I want you to get down here. Now let's go to some examples. All right, adding rational expressions. Now I'm going to start easy here with common denominators, with a common denominator. So notice in this case the denominators are the same, so I'm just coming right out and asking you what 4 over x plus y plus 9 over y plus x is. Remember, these denominators are the same no matter which way you write them. So we can just add the tops together and put it over that common denominator. Isn't that nice? So those are very nice ones when you're given a common denominator. You can just add the tops, boop, got the answer. All right, same thing for the second example. Now notice I made them a little bit larger here. So what we're going to have is 2 fractions with a common denominator of x minus 1. We're going to have to go ahead and collect like terms here. I call this the bird. Do you see the bird there? CLT. I'm going to call it the CLT bird as it flies to give you the answer over here. All right, so when you add the x's, 3x plus 9x is 12x. Minus 2 minus 5 will give you a minus 7. So your final answer here with these 2 common denominator fractions, we just collected like terms and we've got the answer here. Okay. Now, what if they're unlike denominators? This one's got a positive c, this one's got a negative c. Definitely can't just go adding those together like that. But there's that little negative fraction rule we talked about earlier in the course. Let's review that real quick. There's 3 ways you can write a negative fraction. 1, the negative can be out front, minus a over b. Or you could write that with a negative on the top with the a, or you could write the negative on the bottom, as long as you only have 1 negative in each one, because if you had 2, then of course it would become a positive. All right? Now this is a nice little rule when I look at this creature, because if I don't like that negative on the bottom of this fraction, you know what I'm going to do out there? I'm going to take it and I'm going to put it up there with the 7. All right, so that little negative fraction rule can be your friend, because what that just accomplished for me is what? It made something with an unlike denominator into something with a common denominator, and now we can put those 2 fractions together and get how many things over c? 3 plus negative 7? Negative 4 over c. And again, you could write that answer a variety of ways. You could put the negative out front, the negative on the c, but I'll leave it like that. Okay, we'll continue. Adding rational expressions with those unlike denominators. Now they're getting a little larger, don't panic. First and foremost rule is get that LCD. 90% of the battle, folks, is getting the common denominator of these 2 things so you can put them together like we did the previous examples. Now to get it, remember, these are all variables. I made this one kind of nice. Which one has the most x's? First one, x cubed. Which one has the most y's? This one, y squared. So the LCD of these 2, just taking the most of each one, is going to be x to the 3rd y squared. So what I do is I set up the shell, as I like to call it. You know, I like to write them right underneath there, and I call this the coveted young shell. All right, now the second step in our graphic was we wanted to make equal fractions, equivalent fractions with this common denominator. Now how do you do that, young? Well, let's look at this denominator. What do I have to multiply this one by to get here? Now notice I've got x cubed in both of them. I'm missing something. I need another what? I'm a y short. Now, some of the film guys back there and gals are probably saying, well, the instructor's a quart short or something, but we're a y short on this one. And remember, these are fractions. Whatever you do to the bottom, you must do to the top. Rules for fractions. So what we end up with to get this denominator in terms of the common one will become 5y. All right, now how about the second fraction? What do I need to multiply this one by, this denominator, to get my common one here once I establish it? Well, I'm a couple x's short. No cracks back there. And the y's are okay, aren't they? I've got the same number of y's there, so I just need to multiply the top and bottom by x squared. So this will give me 3 times x squared is 3x squared. So now that I have everything in terms of common denominator, some of you might say, let's do that CLT bird there, all right? But there's no like terms to collect here, so the only way you can write this answer is to just go ahead and write, since the like terms won't collect, 3x squared plus 5y over that common denominator of x cubed over y squared. Now, did you ever think you would get to this point where you could take such nasty fractions and put them into common denominators, just using rules we used back in grade school, and get to here? Yeah, that's something that, All right, let's keep going. I want to see if anyone out there recognizes this from previous lessons, the old c minus d over the d minus c. Now, y'all are going, these aren't common denominators, but something familiar maybe about those. I hope so. These are the old opposites. Remember, the opposites reduce to -1 when we reduce the fractions. If we had c minus d over d minus c, it was -1. So they really do go into each other. So what I tell students is you can go ahead and put either one of the two as a common denominator. Now, since c comes before d in the alphabet, I went ahead and kind of put them alphabetically arranged. So I'm going to get this with this common denominator. Now, let's see what I have to do next. Well, I have to make equivalent fractions here. Now, what do I multiply this by to get here? Well, since the bottoms are the same, well, the top's going to be the same. So I like that fraction. All right, I multiply by 1, get the same thing. But this guy, to get d minus c into a common denominator of c minus d, I would have to multiply the d minus c by -1, since these are opposites. Now, do y'all see when I run that -1 through there, I get here, because the d changes sign, the c changes sign, and oop, there it is. But again, these are fractions. Whatever you do to the bottom, you must do to the top. So you know what happens to the d squared? It becomes a -d squared. All right, so step 1, get the common denominator. Step 2, make equivalent fractions with that common denominator. Step 3, add the top. So what we're going to get here is c squared minus d squared. Now again, when we do that CLT bird there, there is no like term, so we'll just write it like that over c minus d. And notice I have step 4 on that graphic, reduce. You always have to look to reduce fractions to lowest terms, and do y'all see something here? Yes, that top factors into the old difference of 2 perfect squares. C plus d times c minus d, and then you can chop chop. Yeah, so the c minus d's cancel out, leaving you with the answer of c plus d. Now, you could put c plus d over 1, but they usually just leave it c plus d, because anything over 1's itself. Okay, let's continue. Yeah, adding rational expressions with unlike denominators. All right, so what do you see in this one? We have to do some factoring of this first denominator, and there's that difference of you know what? 2 perfect squares. Y plus 4 times y minus 4. All right, so anything that will factor first. The first battle here, get the common denominator. You can't add or subtract them without it. Now, how do I get the LCD of these? Well, which one has the most y plus 4s? Yeah, 1. Not hard. Which one has the most y minus 4s? Yeah, 1. All right. There's your LCD. Isn't that nice with variables? I like variables better than numbers. Those numbers, you had to get primes and then take the most of each prime and multiply it together. These, you just pop them right out. So we'll go ahead and set up the coveted shell. Y plus 4 times y minus 4. All right, so we want to get both of these fractions with this common denominator. And how to do it? Well, what does this denominator need to be multiplied by to become this one? Nothing. 1. It's the same thing, so if the bottom's the same, the top stays the same. I like that one again. Good fraction. All right, now this one, however, the y minus 4 needs what to become this common denominator? Well, it's missing the y plus 4. So that's what I'm going to go ahead and multiply both by the top and bottom. So, oh, look what we got going here, Young. Now, how do I multiply these? The old distributive property is back. So lots of good things happening with these adding rational expressions here. So y times y, and this fraction here is y squared. Y times 4 plus 4y. Now we can go ahead and put these two fractions together into one because we have that nice common denominator here, step 3. So we'll go ahead and write that common denominator, and we'll go ahead and put the bird, the CLT, collect like terms, bird over here. And when we add these, we get y squared is the only y squared terms. 2y and 4y gives us plus 6y. Now, will this fraction reduce? Well, some of you look at it and maybe questioning out there. I can take a y out, Young, but when I take a y out, I'll end up with y plus 6 up here, won't I? Nothing will chop. So if nothing will cancel once you factor this, I think it's a good thing to look for. I always tell students to look for that because sometimes there are common things here, but in this case, you can leave either the circled answer I'm putting here, or you could leave the factored answer there as well. You could put y times y plus 6 over that. So no problem. All right, let's continue our adventure. Again, we don't just hit you with the basics, we hit you with the big ones here as well. So we'll go ahead and add these two creatures together. And to do that, yes, we're going to have to factor each denominator. So x squared plus x minus 6, we remember factors into x plus 3 times x minus 2. So, boy, factoring was important, wasn't it? It just carries us over to the end. The difference of squares, x plus 3 times x minus 3. All right? I want you guys to be thinking about the most important part of this problem out there. I want you to think about what is that least common denominator going to be between these two. How to get it. Do you remember? All right, you take the most of each one and any given one, multiply it together. So the most x plus 3's, 1. Okay, the most x minus 2's, 1. And what else do you see out there we need? Ah, yeah, we need this x minus 3 in here. Okay, so that is the common denominator. The most of each thing multiplied together. All right, now, what are we going to do next? We want to make equivalent fractions with this common denominator so we can put these two into one. So this is the shell, I like to call it. So what now, once you factor everything, it's pretty easy. I mean, it looked complicated to start now maybe, but it doesn't take Einstein again. What is this one missing that this one has? See, once you have them factored, it's easy to tell. Well, gee, Young, this one's missing an x minus 3. So we're going to go ahead and multiply both top and bottom by x minus 3, remembering that to make them equivalent, you have to do the same thing to the top and bottom. And there's my little friend, the distributive property. So now when I multiply that and put it up here, it's going to become 2x minus 6. Yeah. And then the second fraction is missing the, to get a common denominator here, it's missing the x minus 2. So we'll go ahead and multiply the top and bottom by x minus 2. And when we distribute and put that answer on the top of this fraction, we'll get 3x minus 6. So good. Now we can take these two and combine them into one by using the old collect like term method, and the bird is back. I usually like the bird to tie them together there. So when we add the x's, we get 5x minus 6, and minus 6 over here gives us a minus 12 all over that common denominator. All right, so we are making progress here. So we have taken them and changed them. All right, so let me go to the camera here. Are y'all starting to feel that power surging in your veins? So we have now talked about these polynomial fractions, rational expressions. We have reduced them. We have multiplied, divided them. We have added them. What's left? Oh yeah, we must subtract these creatures as well. So let's go back to some examples and we'll look at subtracting rational expressions. And again, I'll start out nicely here with some common denominators. All right, so 3 over x minus 7 over x. Now remember that negative rule we talked about earlier? With these subtraction fractions, believe it or not, they're dangerous. I want to take that minus sign and I'm going to put it in the top if that's all right with everyone. So what I'm going to do is distribute the minus through. I'm going to write that as plus negative 7 over x because I think you can see that a little bit better now. Now, a lot of you would have said, Young, I would have got that anyway. I would have got negative 4 on top over x, subtracting those the way it was, and it wouldn't have been no big deal. But where students get in trouble, folks, is one like this where you have, I call these the subtraction fractions, because all of this gets subtracted from all of this in the top. So what I like to do is tell students on these subtraction fractions, you can change them into addition by using that negative fraction rule. You can take this negative sign and run it through the top and change it into addition, and then it's really what we've been doing in the first place. So when you see that subtraction sign, and you notice we have common denominators here, let's just go ahead and change that to addition, and then go ahead and run that minus sign through the top there. It's the same thing. So really we've taken that difficult concept and changed it into what we were doing. So now we can go ahead and collect like terms and put the CLT bird there as it flies in down to here. And we'll end up with x minus 3 plus 7 is a plus 4, and that's the answer, right? Well, always look to what on fractions? Reduce. You know, something's tingling here, Young. Something doesn't look right. Maybe this bottom will factor. Let's try it. Some of you out there are screaming bloody murder. You see factors of 4 that'll give you 3 there, don't you? So it would be xx plus 4 minus 1. You were right to be suspicious. Now, you know, even students at this point, they'll miss these. You know what they'll go ahead and do? They'll say, oh, I got that, Young. Chop the x plus 4s, and you get the final answer of x minus 1. But that's wrong. Now, why is that wrong, Young? Why is x minus 1 not the answer? Because the x minus 1, folks, is in what part of the fraction? Numerator or denominator? Yeah, it's in the bottom, isn't it? I see that as a common mistake in math. Don't go there. Dark place. Hurts. Yeah, so when you reduce anything divided by itself, you get 1, and it would be all over that x minus 1 in the denominator. So be very careful. Not the same creature. All right, so let's again go to some with unlike denominators now, and we'll just keep on trucking here. We're going to be just empowering you with adding and subtracting these fractions, polynomials, variables, whatever. Don't worry about it. So here again, that negative fraction rule, since I have a opposite sign here, you know what I'm going to do with that negative? I'm going to just take it and go, get out of here, and I'm going to put it up here with a 4. All right, so I have 6 over b now, minus negative 4 over b. Now, with the old double negative property, minus a negative, so this would really become 6 over b plus 4 over b, and since they have a common denominator, that'll just give us 10 over b. What do you think? Not bad. All right. Now again, be careful here because on this one, you've got a y minus 9 and 9 minus y. There's the old opposite thing, right? Yeah. All right, so boy, this one's really bothersome students here when they have a subtraction and opposite signs here. So let's go ahead and we can get a common denominator here. But first, let's go ahead and take that minus and run it through. Let's go ahead. Now, where do we want to run it through here? Remember that negative fraction rule? We could run it through the top, or we could run it through the bottom. Now, I think in this case, if you take the minus sign and run it through the bottom, watch what happens. I'm going to rewrite this thing. You'll love it. In this case, if you take the minus and run it through the bottom part of the fraction, leave the top alone, the the 9 minus y, when you hit it with a negative sign, becomes y minus 9. And now we have that common denominator. We can put them together and get, we'll do the CLT bird here. So we'll get a 3y minus y is 2y. Negative 8 plus 4 is going to give us a minus 4. Now we could factor a 2 out of the top, but nothing will chop or reduce, so that would be the answer. All right, so we're making great progress here. Let's go on to some more here. Now again, we'll go ahead and factor this one here. So the first step is to get that common denominator, whether you add or subtract. So on this one, we'll go ahead and factor a 2x out, which will leave us with x minus 1. Over here, we'll factor a 2 out, which will leave us with x minus 1. All right, now before we go doing that common denominator here, and some of you are going, wait a minute, Young, that's a minus. Why are you putting a plus down here? Because you know what I'm going to do with that minus. I'm going to take this, in this case, and run it through the top here. So I'm going to change that to plus and put that negative up here. Okay, now to get the common denominator of these, now notice the numbers are both prime already. So the most 2's, 1. The most x's by itself, 1. Now notice this x and this x minus 1, these are not representing the same number. See, if this is x and it's 5, then this number would be 4. If that's 7, that's 6. So you have to take an x by itself and then an x minus 1. So you make sure you get them all here, each portion of this denominator. So the common denominator would be 2x times x minus 1. Oops, let me fix that up there. Sorry about that. 2x times x minus 1. Now let's go ahead and change these into equivalent fractions with that same denominator. So this one, bottom don't change, top don't change. This one is missing the what? It needs an x. So we'll multiply both bottom and top by x, which gives us a minus 5x. So now we can go ahead and write 2x times x minus 1 in the bottom. Put these tops together and get a negative 5x plus 3 or 3 minus 5x, whichever way you want to write it. And we are in great shape here. So looking at this now, 90% of the battle, get that common denominator. Set up the shell, and then you'll see what you need to multiply by to get that common denominator, and then you can put them together. Now, obviously, this one won't reduce because nothing comes out of the top. All right, so great job today. In closing, remember what it takes to succeed in mathematics. Effort, desire, motivation, drive. Stay focused, pay attention to detail, always feel you can succeed. You may be surprised with the results. Take care, we'll see you next time.